Hello, good morning, and welcome to today's Wired briefing, Why Tech Will Always Need the Human Touch. I'm Amit Katwala, I'm a senior writer here at Wired. Thank you so much for joining us for what we hope will be an interesting and thought-provoking session. Today, I am delighted to be joined by three speakers to discuss how we can strike the right balance between humanity and technology, and how to assess the risks and rewards of new technologies. Joining us for this discussion is Caroline Gorski, the CEO of R² Factory at Rolls-Royce. Caroline has spent 25 years analysing, advising on and managing strategic change at the cutting edge of technology development. We're also joined by Orlando Machado, Chief Data Officer at the Lego Group, who has spent over 20 years helping organisations get value out of their data. And finally, Chris Oxborough, who is the Head of Technology Risk, Data and Analytics at PwC. Over the last 10 years, Chris has worked on some of the UK's largest and most complex technology-enabled transformation programmes. Welcome all, it's great to have you with us today. Now, for the audience, please remember you can submit questions to the panellists using the Q&A functionality, and we will try to get through as many questions as possible at the end. Before we dive into what's going to be a fascinating discussion, I'd like to quickly hand it over to Chris, who would like to say a few words.
Thank you, Amit, and hello, everyone. This is a really important subject, and because we're all used to using technology to automate decisions for things like workflow, but these always have kind of followed predefined criteria, and anything that doesn't follow those tightly defined criteria will get effectively diverted for human review. But now we're talking about much more powerful data analytics tools to automate decisions using AI models, and it becomes less and less easy to explain the outcomes without utilising new techniques to deliver explainability. So this requires a change in the governance structures within organisations to ensure that these powerful tools are designed, implemented and reviewed consistently to ensure outcomes sit within what organisations consider to be acceptable. This is why PwC helps clients to identify potential risks and proactively manage them to allow businesses to innovate safely at speed, and why the discussion around the amount of human involvement in technology is really important.
Thank you, Chris. So to kick off, I think it would be great to understand from our panelists what the right balance looks like. As Chris was describing there, it's important to get the right balance. So Orlando, maybe you can start by sharing some insight from your experiences at the Lego Group and telling us what the right balance between tech and human looks like for you.
Yeah, and I think it's important that people don't expect that there's one sort of cookie cutter answer to this. I think it's all down to the problem that you're trying to solve. It's all down to the benefits of the outcome, and it's also down to the sensitivity of the data. Chris was mentioning AI algorithms. These are data-driven techniques, and I think people have gone wrong in the past where they haven't considered the input data enough. You can be very seduced by machine learning or artificial intelligence, but one of these, the old garbage in, garbage out adage is still very true. I think in terms of the balance between humans and technology, if you think about what we're trying to do at the Lego Group, it's anything from trying to use connected devices to help us with calibration of molding machines, all the way through to trying to moderate the content that children are seeing on social media apps that we provided for them. And those are very, very different situations. If we're thinking about molding machines, this might be a very important source of intellectual property, but fundamentally the data might be less sensitive. So that requires a certain degree of human oversight. But if we're thinking about how we moderate the content that children are seeing on an app, we would typically have a lot more human oversight. We'd use artificial intelligence techniques to reject content, but if we're going to accept content that kids are seeing, we'd always want some kind of human moderator. So I think that the key thing is trying to think about the problem you're trying to solve, try to think about the benefits and the risks, and apply the right kind of balance accordingly. Don't try and look for one sort of standard answer to this question.
I think you raise an interesting point, and I guess the two examples you gave there are examples where, one example where maybe machines are perhaps better at measuring the tolerances of a Lego brick to a fraction of a millimeter, and people are probably better at deciding whether or not a piece of content is going to be potentially harmful to children.
Absolutely.
Right? Caroline, so I suppose you're probably coming at this from more of the manufacturing or perhaps the first example that Orlando mentioned there, but it'd be interesting to see what you think is the right balance between human and tech and how you're doing this at R² Factory.
Yeah, so R² Factory helps Rolls-Royce and other industrial clients to think about the application of advanced data analytics, machine learning and artificial intelligence into industrial use cases. And I really liked how Orlando talked about that that range of answers to this question. Because for us, many of the processes we are helping customers with are either mission critical or indeed in some instances safety critical processes. And here, what we're really interested in is the augmentation of human capability with machine capability. And this is about understanding which processes are actually delivered better by machines, by machine intelligence and by artificial intelligence, and which processes are delivered better by human intelligence. Even when you're talking about, manufacturing processes, and that you rightly call out, there might be some parts of that activity which machine intelligence is far more accurate in being able to provide answers to. There are still certain points of oversight where, when you're thinking about a mission critical process or a safety critical process where potentially human lives depend on the accuracy of the answer, you still need human knowledge, human governance, human oversight, and actually the kind of tacit experience that's built up from domains over decades to be able to assure that that quality is present.
Chris, did you have anything you wanted to add on that point?
Yeah, I think both Caroline and Orlando raised a really interesting point about what we would call use case criticality for where you're using effectively the sorts of technology. So, things like recommendation engines, the risk of it going wrong is you might waste an hour watching something that you don't like. But you're thinking about medical diagnosis, for example, even though increasingly the AI is actually better at spotting potential cancerous cells, people still would prefer to have a doctor in the loop to check it. And so that kind of concept of, I guess, what does the end user see is really important in terms of determining how much human needs to be built into, I guess, decision making.
I think that's a really interesting point, and I think there's a point to which you're right, Chris. It's about what you can present to the end user, and people might feel uncomfortable if they knew that an AI was making that decision, particularly, Caroline, perhaps in an industry where safety is so critical.
Yes, and I think just to build on that point, there's a really interesting paradigm that we're likely to come up against some point in the next 10 to 20 years, which is the challenge we face when we have a mixed set of control mediums that are still overweighted in favor of human control mechanisms and underweighted in favor of machine control mechanisms. And I'm thinking here particularly around things like autonomous vehicle controls, because realistically, you get to a tipping point at about 30 to 40% of autonomous control where your general population is safer because you have more machine decisions happening. But until you reach that tipping point, you're in a really quite high risk space, because when you've got some machines making autonomous decisions, but the majority of decisions still being made by humans, it's very hard to predict how those humans are going to react. It's very easy to predict how the machines will react, but it's very hard to predict how the humans react. So you actually create a much more complex optimization and modeling scenario for your autonomous control compute to work within. I think the next 20 years is going to really stretch the boundaries of some of how we think about human oversight, the legislation that we need to manage liability in this context, and also what it means to be living in this world.
I think that's a really interesting point, and that's one of the reasons why autonomous vehicles are so difficult to get right. It's not because we can't program a software to drive a car around a track or in a closed environment. It's because autonomous cars need to be able to predict what humans are going to do, and that's the real challenge. So to build on that, I'm interested in how, and Orlando, maybe you can kick us off on this, how the AI and the human works together at the Lego Group, for instance, and how you get that balance right and how they collaborate, I guess.
Yeah, and I think Caroline mentioned the idea of augmenting human processes with machines, and I think that tends to be the way that we look at things. I quite like using AI to mean augmented intelligence, and I think the idea of just trying to see how we ensure that humans do the things that humans are good at and machines do the things that machines are good at. Humans might kick off the process, humans might provide training data. One of the things that we can do is what machines can provide is scalability and speed. So once we have a problem that's very, very well defined, we'll look into how we can get a machine to automate that. Now, I think the challenge is often how you define the problem in a way that's well specified so that a machine can take it over. And I think you see, when you see examples and headlines about AI going rogue or AI going wrong, or Microsoft's Twitter bot turning racist, it's quite often because the problem isn't well specified and the boundaries aren't really defined enough. If you start to let something loose in a very open situation, I think there are lots of risks. If you could have something that's very, very well defined, then I think the risks are mitigated. So that tends to be the approach that we look at. We try to look at the problem we're trying to solve, the level of human oversight, and then the way that we can augment the human process with machines doing the things that machines are good at. And I think we tend to spend a long time maintaining the human oversight, because we're a fairly cautious company, mainly because a lot of our main consumers are children. We tend to take an extremely conservative approach to trying to let anything loose. In fact, we don't, we wouldn't use the terminology like trying to let AI loose. It would always have a very high degree of human oversight. And that tends to be the way that we look at things. But I think the concept of augmented intelligence, I think, is a good one, trying to work out how we get humans to do the things that humans are good at and machines to do the things that machines are good at, but working very closely together.
That's really, really fascinating. Thank you, Orlando. Caroline, does that resonate with your experience as well?
Yes, absolutely. I mean, let me give you an example from within Rolls-Royce. Over the last 40 years, we've been working with advanced data analytics in the support of our predictive maintenance services for airplane engines. So this really underpins the power by the hour proposition that we started bringing to the market some time ago. But over the last 10 to 15 years, we've been building that capability out with artificial intelligence, and that's allowed us to move from being able to react to relatively well-established signals of engines in use to help us understand when they need to be brought in and maintained, to a predictive maintenance capability which can simultaneously optimize across 26 independent variables in a three-minute turnaround, in order to make 70% of the sentencing decisions about whether or not an aircraft engine needs to have its maintenance window pulled forward or pushed back. And only then to need to present the edge cases to humans to be able to provide their insight and attention to. That allows us to offer a much more effective maintenance program to our customers. It allows our customers to operate their aircraft more fuel efficiently as well as more cost efficiently. And that means they burn less jet fuel, so they end up producing less carbon. So the net impact of being able to put an AI which can see emerging new faults coming out of 26 variables, which no human could ever do, because humans can't hold that much information in their brains simultaneously, is helping us not only improve the performance of those machines across their life, but also helping the customers who use them to lower the carbon impact of what they're using those machines to do.
I think what's interesting, and I don't know how this is framed when you kind of market it to your clients, but I guess they don't necessarily even need to know that AI is involved in this. They're paying you per hour for the use of a jet engine, and actually the fact that you're using AI behind the scenes to make that much more efficient is perhaps not irrelevant, but it's not at the forefront of the end user's mind here, I guess.
You're right about that. What we do in this business model is we understand that the data, although it's being generated by our engines as they're being used, belongs to our customers. So we work with that data as in trust, in order to provide an improvement to the service for our customers. But ultimately, it's their data, and that's quite an important nuance, even in the context of a business-to-business service like I've just described. It's certainly an increasingly critical nuance when you start to think about a similar type of relationship in the business-to-consumer space. Ultimately, who owns the data that I generate when I am consuming media, and that information is being then sucked into an AI optimization engine to present me new choices? That's a very unclear space right now. I think that for me is a clear potential area of risk that we still need to do some more work on. And it's really important when you're talking about safety critical or mission critical processes that the ownership of data is clear, even if it doesn't reside with the end customer. It does need to be very clear, because where you're obviously making a recommendation about the effectiveness of a physical machine in operation, you need to be very, very clear about where the liabilities sit in understanding the recommendation. and whether or not they are taken up by the user of that machine.
You also raise another interesting point, and maybe this is something that Chris or Orlando can chip in as well, is that if a machine learning algorithm is developed using data that belongs to a specific customer or a specific person, who owns that algorithm as it gets rolled out? And Chris, maybe you've got some examples of like the best way to implement this and to kind of deal with this challenge of who actually owns the data and who owns the resulting things that are built from that data, even if the actual data is no longer attached to them.
I mean, that is a really interesting question, because under GDPR regulation, individuals have the right to actually understand how their data is being used and how it actually works within automation. Which makes it really difficult for clients and for us, because at the end of the day we'll use some data, and if a customer comes back and says they want that data deleted, we might have to go back and retrain models taking the data out. It might not be possible to actually identify the data. So it does open up an interesting can of worms, which the regulation yet hasn't really caught up with.
I agree with that. I agree that the regulation, I think, needs some time to mature, because I don't think it's at all clear what kind of level of explanation consumers actually want when it comes to understanding how the data is being used. I think presenting a consumer with an algorithm would seem to be an unhelpful thing to do. I don't think anybody really wants that. But where do we get the balance right? How do we actually understand really what consumers want? Because we know that at the moment consumers are slightly conflicted. People are, there's very high awareness of privacy concerns and security concerns, and people don't want their data being used in ways that are inappropriate. But at the same time, people expect the data to be used in a way that makes services better for them. People expect not to have to tell companies the same thing twice. And so how we navigate that, I think, is still slightly uncharted territory. I think it's slightly early, and I think we're going to need to work out as we go along the appropriate level of use of data and the appropriate level of transparency when it comes to consumers. We can be very transparent about what we're doing, but how are we transparent in a way that's actually helpful to people? I think that's something that everyone's working on.
Yeah, and Chris mentioned GDPR, and GDPR is perhaps the quintessential example of a well-intentioned attempt to do what you were describing, Orlando, that has not really made things better for consumers. In fact, it's made things a lot more annoying for a lot of web users, right?
Yeah, I mean, I think the number of pop-ups and the number of things that you need to accept, I think it's unclear that that's helpful to consumers. I think that you're right, it's well-intentioned. And I think we should all aim for the right level of transparency. But I think, again, it's an example where a one-size-fits-all approach doesn't really work. And I think that's different for different industries. If you're working in financial services and you've got levels of regulation, and it's different for the different use cases. Again, this idea that you can have one sort of solution that works for everything, I think is where we're going wrong.
Well, I was just also going to call out that there are challenges with data, even in industries and in use cases where GDPR doesn't apply. So much of what we do for our industrial customers, it doesn't touch GDPR because we are not dealing for the most part with personal data. What's fascinating from the industrial use cases for AI is that in many instances, failure event data, which is often what you're looking for in order to predict, an understanding of how a physical machine or a component within a machine is going to work across its life. Failure event data is, generally speaking, extremely scarce in most industrial data sets, and that's a really good thing. We are all really grateful that big, heavy industrial machines fail very infrequently. It means that companies have done a great job in their safety management processes. But if you're trying to train an AI or a machine learning algorithm to predict for a catastrophic failure event, you have a real problem, because there is not enough in the data set to be able to actually to develop the features and the relationships to be able to do that prediction. It's one of the reasons why there are two themes that I think are going to have to really come to the fore over the next 5 years. One is collaboration at the industrial level in order to address this data scarcity problem. But the second is an understanding of the use of synthetic data and the right regulatory approach to the use of synthetic data. And that's a very challenging point when you think about some of the guidance that's coming from, for example, the EU around general adversarial network use and the development of deepfake technology, which is essentially synthetic data creation. Of course, we don't want to use it to, you know, create deep fakes of presidents spewing, you know, anti-democratic messages around the world. But we might want to use it for creating accurate synthetic models of complex machines in order that we can understand when they're going to break.
So I guess my question there is that in these incredibly complex systems where failure is very, very, very rare, is a synthetic network ever going to be able to recreate that 1 in a million event that was a confluence of a combination of the weather, a particular day, you know, pilot error, or, you know, a huge, you know, confluence of things, a butterfly effect scenario? Is AI ever going to be able to catch those problems? And is there a risk that it perhaps lulls us into a false sense of security?
Well, I think my answer would be that's not what we are, for the most part, using synthetic generated data to do right now. So many people, and I'll put my hand up and admit, when I first joined this industry 5 years ago, I had no understanding of quite how poorly prepared for machine learning and AI most industrial data sets are. So actually, there is a whole role for synthetic data in generating much more basic level input data in order to create the possibility for higher level abstractions, which would then be supervised by humans. So let me give you an example. We last year used general adversarial networks to create a database of crack images in a particular type of metallic structure. Because those cracks happen very infrequently, because we do a very good job of making those structures. But without having enough of those crack images to be able to train an AI, we were not able to even deduce the relationships that would show up real cracks appearing in our data set. So that's actually using synthetic data not to do whole optimization activity. It's just using synthetic data to create enough input information to be able to present into an ML, which can then show its recommendations to a human to manage some of that much more complex analysis that often comes from very tacit understanding of how complex machines operate across their lives, and with all of the inputs that the more contextual inputs that you've mentioned. So the short answer to your question is, I think we will get to a time when more of that complex modeling is done using ML. But right now, we are at such a basic input data level that we actually need to clean up the input data using AI and ML techniques themselves, just to get us out of the starting blocks in many instances.
It's really, really fascinating. I'm interested, Orlando, in whether you have used AI at the Lego Group for some of those more creative processes, whether it's something that kind of feeds into the, I guess, the more creative side of what you do in terms of coming up with new product lines, or simply kind of doing art, I guess.
We're interested in things like how we can understand the characteristics of a product that is really appealing to people, and how then when we develop a new product, we try to match some of those characteristics. So yeah, that's an area that we're researching actively. We also use a lot of data-driven insights when it comes to the creative process. So we have lots of data on what's worked in the past, what hasn't worked, what the kind of things that people like, and our creative designers will use that kind of data as insight in probably a little bit more of a traditional way. It'll be inspiration rather than some kind of automated decision making. But it's something that we're really interested in. We're interested in how, Chris was talking about product recommendations. We're interested in how we can make product recommendations that are inspiring rather than just sales driven. How do we think about a product that somebody might like next? Because we have so many products now, we have so many different types of audience. Historically, our main audience has been kids. Some of you might know that adult fans are one of our biggest growing audiences, although kids are still our sort of core audience. And how do we make recommendations that recognizes that? People might want different kind of experiences. People might have different levels of expertise. So some things are very complicated to build, some things are a lot simpler. So we're interested in how we inspire our consumers and people that are playing with our product to take the next step into something that is a bit more creative. And we also use a lot of data-driven insights when it comes to inspiring the creative process.
Yeah, thank you. That's really, really interesting to hear how it's kind of used in different industries. Chris, I wanted to come to you with a question about explainability, which you mentioned at the top. And I guess the question is, as we get these more and more complex algorithms being developed using things like machine learning, often they might be not understandable to humans. So my question to you first, Chris, and maybe the others want to chip in afterwards, is like, how can you keep a human in the loop when you're dealing with something that's perhaps a black box and it's not necessarily explainable or understandable to anyone, let alone, you know, the average consumer?
It's a really interesting question. We spent actually a lot of time building tools here that allow you to kind of unpick the black box and understand what's effectively driving the outcomes, and that does allow you to identify the key features in a model, and that does mean that over time you can go back and re-review a model and see whether there's drift, because you can end up with drift over time as it starts to process more data. So I think, you know, some of the cases we've talked about today, particularly where kind of mission critical or safety critical, humans will always need to be in the loop for the time being until we build up that level of trust. And that trust will only come with being able to actually explain to the end users how these tools are actually working. Or importantly, the trust builds up from the end users with the organizations. And so as long as the, you know, organizations are trusted and can demonstrate that they're doing the right things, again, you can build that trust up with organizations rather than directly with models.
I think what I'd add to that is that the field of explainability and the field of algorithmic fairness, I think these are fast-moving fields. There's a lot of very active research going on, which I think is great, because I think the more tools that are available to help people understand what's going on in an algorithm, I think the better. I think I'm a big fan of using things like checklists and trying to understand various ways that you can mitigate against risk. And I also think when it comes to some kind of automated decision, you need to think very carefully about the downsides of a bad decision as well as the upsides of a good decision. And that can allow you to put the right kind of control in, whether that's human control or another machine control that's kind of rule-based. I think as long as you're very conscious of the downside of getting it wrong, I think you're in a much better place.
I would very much agree, and I would also say I'm really grateful that Chris and his team are you know, spending the time and the effort looking at explainability and helping their clients and other, you know, big industrial organizations like the ones that we work with to think about explainability. It's really important, but I'd also say that trust question isn't simply addressed through explainability, and let me give you an example of why not. When you get on an airplane as the user of an airplane, how many times have you actually asked the pilot to explain the physics of thrust to you? I expect it's zero. There might be a few examples of someone who goes to the pilot and says, tell me why it is when I get on this airplane, the physics that you're going to follow mean that this plane is actually going to take off and stay in the air. But it's so small as to be, you know, in effect, approximately zero people ask that question. They get on that plane and they trust that pilot because there is an entire branch of science, there is an entire regulatory environment, there is a whole safety context wrapped around that process. And sometimes it goes wrong, which is awful, but for the most part, it doesn't. We are rapidly approaching the deployment of some of these techniques into processes that need to have the same degree of trust coming to assure users that they can simply use those processes without necessarily having to be presented with an algorithm, right? Because A, users won't ask, and B, if users don't ask, then there is a risk that companies won't do a good job of this. So we need regulation. We need companies to be required to publish the frameworks that they're using, to be transparent about how they are assuring the safety of the tools that they're building. That's why Rolls-Royce published the Alethea framework 2 years ago, which is, it's our checklist that says this is how we get comfortable in a regulated environment that the machine learning we're using can be trusted to deliver a safe outcome. One of the things that's been really heartwarming about publishing that under open source and sharing it with others is that other people from other industries are beginning to take it and adapt it and learn from it or add to it as well. And that, I think, is where we need to get to. We need to get to a place where all organizations are able to stand up and say, this is how we treat this technology, these are the rules we set ourselves, and this is why we believe it can be trusted. That might include full explainability, but it also might simply be we have these quality assurances for inputs, and we have this way of measuring and assuring outputs.
It's a really, really fascinating and a challenging place for companies to be. We've got a little bit of time left, so I've got one more question for everyone, and then I'll throw it open to the audience to ask some questions. So please do submit questions via the Q&A function if you haven't already. So my last question for all three of you, and Orlando, maybe you can kick us off, is basically what advice would you give people or companies embarking on the same journey that you've been on, or that you're, I suppose, in the midst of?
Yeah, I mean, I think what I say is try and think about the problem you're trying to solve before you think about the technology that you use. And thinking about technology has two risks. One of them is that people can be scared. You know, people think about AI or machines taking control or all these kind of sentient beings or whatever. You can be scared, and that can impair your judgment. You can also be seduced by technology. People want to hire data scientists, or they want to build neural networks, or they want to do, you know, generative adversarial networks, whatever. But I think that's getting it the wrong way around. If you think about the problem you're trying to solve and then pick the right tool for the job, and, you know, that might be something sophisticated, but it might equally be something very, very simple. I think that's the way around I would go. And that problem might be very different. You might be trying to solve a range of very, very different problems, which might require a range of very different technologies, and you should be happy with that.
Caroline, your thoughts?
So essentially, I would say there are three big headaches with trying to develop machine learning and AI for application into industrial use cases. One of those headaches is expensive, but ultimately solvable. And that's the recruitment and application of data scientists and data science to your problem set, right? The other two headaches are in some ways much more intractable. The first is, how well engineered is your data for training machine learning models in the first place? And I promise you, in almost every instance, it's much less well engineered than you could ever imagine it to be. But the other challenging problem, and the one I would like to leave with the audience, is actually how operationally ready is your business to incorporate AI into its human workflows? Because it doesn't really matter how good your data science community is, or even how good your data is. If you haven't done the digital cultural transformation work that helps your business to get comfortable with applying AIs into human workflows, and that helps to reskill and retrain and lower the anxiety of your people, then you can have the best data science in the world, and you might as well have put them in an ivory tower with a pile of 50-pound notes and a box of matches, because you're not going to generate the value that you need from those processes that you're trying to deliver if you haven't brought your people and their skills on that journey with you.
That's a really interesting point, Caroline, because as a global firm, we've invested in something called New World New Skills, which is helping our clients develop their new skills. But importantly, we've trained every member of the firm in things like Alteryx and RPA tools and things like that, just so they're comfortable with that, because we can't possibly help our clients if our own workforce isn't comfortable with the sort of techniques that you're talking about. So that upskilling and getting people ready for technology, what they'll see out with businesses, is really important.
Right, I want to move on to questions. We've got a few minutes left. So first one is, and feel free to jump in, anyone, what happens when we get the balance between human and machine wrong?
I can have a go at that. I think headlines are often very concerned with where the balance has gone too far in favor of machines. And I think we're talking about autonomous vehicles, you know, if there's some kind of fatality, clearly that's a tragedy. And I think, but headline writers are very concerned with these areas, which are extremely rare, where you know, technology has sort of taken over in the bad way. I think probably more often is when we don't have enough technology, or when the culture, to Caroline's point, doesn't adopt it in the right way. And we get kind of faster horse challenges where people say, well, I used to email this report to this friend. Oh, I found a way of automating the way that this email can go to my friend. You know, rather than trying to rethink the problem in a way that is much more fundamental, that uses technology in a slightly more profound way to try to change the process, rather than just trying to optimize within an existing process. So I think a lot of well-established companies are not yet using technology enough. That's probably a cultural challenge more than it is a technical challenge. But I think that's what we're seeing. We're seeing the kind of preservation of inefficient and maybe damaging processes because companies aren't yet ready to take on technology as much as they should be.
I think that's a really interesting point, Lana, because there is a narrative, isn't it, that technology is going to cost jobs and people will be unemployed off the back of it, whereas in reality, what it means is people will be looking for, if we train people with the right skills, they'll be doing new jobs. It's just the jobs that they'll be doing just may not exist at the moment. But then that's something that we've always had through human history with automation, where the old jobs are gone, but new jobs are right off the back of them.
Absolutely. We've got a question for Caroline, but I think it's probably applicable to everyone. How can companies find the right balance between publishing their external approach around AI, as you mentioned, Caroline, about Rolls-Royce had published some of their AI work, without exposing IP? So how do you balance this need for transparency with the need to keep IP sort of private?
That's a very good question, and I'm smiling because it's a really challenging question for the role that I occupy in what is an engineering and manufacturing organization, right? So the world I come from, which is a digital world, is all publish it all. It's open source. You're moving so fast that even if you've published your IP, you're still going to be able to capitalize on it so quickly. You'll have faster movement, first mover advantage, and therefore you can be free and open with it. Think about Tesla, for example. The world I sit in now is a deep, 25, 30-year product development cycle, complex, bending the rules of physics world, where IP protection is incredibly important, and a very clear boundary measure that's used to maintain competitive advantage. The approach that we take is one where we, in our Squared Factory, focus on collaboration. So our first foot forward is collaborative and open. We protect data, we protect our customer data, and we protect our data. But for the most part, we are extremely collaborative in our approach. We genuinely believe that that's the right approach. So whilst we do place IP boundaries around the specifics of what we might make in terms of products and applications and models, we try to wrap that around the smallest possible kernel of IP. So as much as possible is shareable, on the basis that helps the market grow faster.
That's really interesting and a really interesting challenge. Orlando, I don't know if it's quite the same for Lego with in terms of, because I suppose the whole thing is you've got the building blocks and people are free to go off and build whatever they want with them, right?
Yes, I think a lot of our processes are quite IP heavy, but I think it's a kind of general point. If you're trying to think about IP, quite often the focus is on the machine learning part or the algorithm or the technique, but the reality is that the IP often sits in the raw data. And so it can be the case that you can be quite open about sharing methods or techniques. It can be the case that you can collaborate with academia and publish all sorts of things while still protecting the IP, which ultimately might sit in your own data. So I think trying to work out the balance is often about just trying to deconstruct the problem into where the IP really sits. And I think if people analyze that, then I think that opens up the opportunities for a lot more collaboration.
Yeah, that's a really interesting point. And I guess, it's your ability to use AI to do predictive maintenance on jet engines or to figure out what a customer wants in terms of a new Lego set comes from that vast pool of data that you've got from doing this for so long. And that's, as you say, where the key IP comes from. I've just got one last question from the audience around regulation in tech and what actions can or should be taken now to regulate this kind of technology. I know there's a proposed AI Act from the EU, which has been mentioned as well, but what do you guys think needs to happen or should happen?
I have a number of concerns with the proposed EU Act, not if I'm really honest with what's in the Act per se, because I think much of it is very well reasoned and very effective, but it's also very general, it's intended to be generally applied across all sectors. And that's where my hesitation and my problem comes. I think we need all regulated sectors to develop their AI competency so that AI regulation can be sector-led as well as having a general approach. And I think that's important because Orlando's very opening point, which is it depends what the use case is that you're using this for, also applies in the regulatory context too. I'm worried about too broad a brush being applied. I'm worried both because that will be too restrictive for some sectors and not restrictive enough for others. And what I would like to see is much more upgrading of understanding of these technologies in the context of the individual regulatory bodies that control industrial areas, so that we can really properly think through some of these questions about how do you use these techniques to do work which can be trusted, which is safe, which is effective, and which augments human life.
I couldn't agree more. I think that regulation does absolutely need to be sector-led. I think there needs to be this really deep understanding of techniques. And I think that needs to start with regulators actually, employing people that might be deep technical specialists, or, deepening the understanding within the regulator organization. Because I think without that kind of understanding, you can lead to these sort of knee-jerk responses that don't get the outcome that are required because the understanding of the technology isn't there yet.
I'd agree with that, because there's also a risk that regulators default to the answer is no, without having the understanding about how you make the answer to be yes, but with the right guide rails around it to protect consumers and users of whatever the service is. So it is definitely something where regulators, I feel, need to catch up. We've seen some good progress with regulators, but there's still, I think, progress to go.
It's going to be a really, really interesting challenge for regulators, for companies, and for all of us, I think, to navigate this exciting new field over the next few years. With that, we're just about out of time. So I want to say thank you to Caroline, to Orlando, and to Chris for taking the time today and for sharing your insight. And thank you to our audience for watching. If you enjoyed the session, please do check out our other Wired virtual briefings at wired.co.uk. Thank you so much, and we'll see you soon. Cheers.